Alright, so here is your second video for this week. This one's about functions and relations, and it's really just about identifying what's a function and what's a relation, and we will get more in-depth into functions later on. But let's do definitions first. That's always the most fun. A relation is nothing more than a set of ordered pairs. And you'll see what I mean. We'll have some examples in just a minute, but it's just a set of ordered pairs put together. Okay? They can be pulled from a graph, from a table, or they can just be given to you. It's just a set of ordered pairs. A function is the important one. A function is a relation where every x value is paired with exactly one y value. And that word exactly is important. The thing that you really need to understand about a function, there's lots of things to understand about a function, but the thing you need to get from this definition is that x values in a function do, that's an O, not repeat. And so if you have a relation or a situation where you have x values that repeat, then what you have is not a function. And you'll see, we'll do several examples so you understand what I mean. But what you really need to get is that x values do not repeat. Okay? Alright, so let's do some examples. There are several ways to represent a relation. You can write it out like this. This is what we call a set of ordered pairs. It is a set because it has the squiggly little brackets around it. That's what makes it a set. Then you've got 1, 2, 3, 4, 5 ordered pairs in there. The first question says, is the example a function? Well, if in order to know if it's a function, I have to look at my x values. Here are my x values, 2, 3, 4, 5, and 6. Are all of those x values different? Yes, I've got a 2, I've got a 3, a 4, a 5, and a 6. None of those values are repeat. None of them are the same. So they're all distinct, different values. Since none of my x values repeat, yes, this is a function. If I want to list the domain of this function or this relation that I'm looking at, remember domain is all of the x values, so I'm just going to list my x values. I have 2, 3, 4, 5, and 6. My range is all of the y values, and I just need to list them. But the big important thing you need to remember is that it must always be in order from least to greatest. So my range values are 5, -2, 3, 1, and 3. Well, the 3 repeats, which is fine because it is a y value. It does not affect whether or not this is a function. It will affect how we write our range, however. -2 is the smallest. Then we have a 1. Then we have the 3's, but I'm only going to write it once because we don't write repeating values. And then you have a 5. So there's your domain and there is your range. Now if I'm going to put it in a table, I just list my ordered pairs in the table. I have 2, 5, 3, -2, 4, 3, 5, 1, and 6, 3. Okay? So here's one way to write it as a set. Another way to represent it is as a table. Another way to represent this as a graph. And so as a graph, I just plot these points right here. So I would start with 2, 5, and then I have 3, -2, and then I have 4, 3, and then I have 5, 1, and then I have 6, 3. That's what it looks like as a graph. And since it's just a set of ordered pairs, this is a discrete graph. I will not connect the points. That's what it looks like. Mapping is the only way to represent a relation that you have not ever seen before. A mapping is not difficult. In a mapping, this is your x and this is your y's. And when you put your values into the mapping like you did into your table, the only difference is you don't just list them in orders, all the x's and then the y's that go with them. You list them like you do for your domain and your range. So in your x oval, you list your domain, which was 2, 3, 4, 5, and 6. And then in your y oval, we're going to list our range. And we're going to list our range just like we wrote it out when we wrote the range, in order from least to greatest and no repeating values. So I have -2, 1, 3, and 5. And a mapping is exactly what it says. I am going to map or show how these x's relate to these y's by drawing arrows. Which ones go with which? Well, from my table, the 2 went with the 5. So the 2 goes with the 5. The 3 goes with the negative 2. 4 goes with 3. 5 goes with 1. And the 6 also goes with the 3. And so that's what the mapping looks like. All it is you list the numbers in order from least to greatest in the X column and the Y column, just like you do domain and range. Don't list repeaters. And then you just draw the lines to connect the ones that match together. Let's practice one more. Excuse me. Okay. Here I have my relation all written out nice and pretty. And the first thing we're going to do is we're going to list the domain. So that's all the X values. Well, I have a 0 and another 0. So I'm only going to list it once. Then I have a 2, a 3, and a 4. There's my domain. Then my range is going to be all of my Y values, and I'll put them in order from least to greatest. So I have negative 1, 1, 2, there's a 0 here. It's negative 1, 0, 1, 2, and 4. And I almost forgot my 0, didn't almost have it in order from least to greatest. But there's my domain and my range. What you should notice is that your domain is shorter than your range. The reason is because you had an X value that repeated. You have a 0 and a 0. Since I have a 0 show up twice in the X values, this is not a function. I don't see the question, so we're going to make sure we write it down. It's not a function, and it's not a function because those X values repeat. So let's put it in the table just to fill in. So I have 0, negative 1, 0, 1, 2, 2, 3, 4, and 4, 0. And then to put them on the graph, you just plot the points. Oh, there's the question. We'll come back to it, though. So I have 0, negative 1, 0, 1, 2, 2, 3, 4, and 4, 0. And again, it's a discrete graph. We will not connect the dots. But when I put it in a mapping, these are X and these are Y. And so I have 0, 2, 3, 4, because that's what I wrote as my domain. And then my Y, over here, I have negative 1, 0, 1, 2, and 4. That's my range. And then I just connect them. 0 goes with negative 1, 0 goes with 1, 2 goes with 2, 3 goes with 4, and 4 goes with 0. And the thing that you should notice is this 0 has 2 lines leaving from it, which tells you automatically that it repeats. And you can see that from the relation there. You can see it from the table. You can also see it on the graph, because these two things line up, meaning their X values are the same, which is going to be important in a minute. So no, this is not a function because you have X values that repeat. And it cannot be a function if X values repeat. So now let's look at something called the vertical line test. The vertical line test is really, really important. It's very, very easy. It is something that is so easy that people try to make it really difficult. It is very easy, okay? The vertical line test is nothing more than a test that is used to determine whether or not a relation is a function. If any vertical line crosses the graph of a relation more than once, then the relation is not a function. For example, this graph that we just did right here that was not a function. If I were to draw a vertical line right here, it would cross through this point and this point, so it would cross this graph twice, making it not a function. But we're going to practice some. Here's how I do this. I don't have a pencil that I can just drag across my page here, but what I can do is I can make a vertical line. So I'm going to draw a line. Your pencil will work just fine for this, by the way, just so you know. So I have a vertical that's not vertical yet. Okay, so I have a vertical line here. This is my vertical line, and this is what I'm going to use. To test to see the vertical line test, what I do is I take a pencil, or in this case, my pretty little vertical line, and I'm going to start it on the left of my graph, and I'm just going to start dragging it across my graph. If at any point this vertical line touches my graph in more than one point, what I have is not a function. And if you will notice, my vertical line here touches this graph here and here. And if I move it, it still touches it here and here. And if I move it over here, it still touches it here and here. Any vertical line, doesn't matter where you put it, if any vertical line touches the graph more than once, what you have is not a function. So this is not a function. That's a really ugly N. This is not a function because that vertical line touches that graph in more than one point and all over it, okay? In every place possible. So let's test it again. Let's use this vertical line and let's look at this graph. Well, if I take my vertical line and I start dragging it across this graph from left to right, it touches it in two places, here, 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 all the way until it gets to here. But that point doesn't matter because every point in between, it touched this vertical line, touched my graph in more than one point. So again, this is not a function because my vertical line touched my graph in more than one point, which means what it tells me is that my x value here is the same as my x value here, and so I have x values that repeat. That's why the vertical line test is important. It's also really easy. So let's test another one. Well, the next one's pretty simple. I have a vertical line. If I put my vertical line on top of that vertical line, how many times does my vertical line touch the vertical line that was already drawn? It touches it everywhere. It touches it from the top to the bottom. It touches it in more than one point. If you look, this is why we use a vertical line, because a vertical line itself is not a function. The x value here is 7. The x value here is 7. The x value down here is 7. It doesn't matter where you are on that graph. The x value is always 7, which means you have repeating x values. This is not a function because the x values are the same. You can't have repeaters, which, like I said, is the reason we use a vertical line to test for a function, because a vertical line is not. It's the opposite of a function. So let's test this next one. If I take my vertical line and I drag it across, there is not a single point on that graph where my vertical line touches that graph in more than one point. It touches it only once over here. It touches it only once over here. Touches it only once right in the middle. Doesn't matter. Your vertical line never touches that graph in more than one point. Therefore, this is a function. And I realize y'all don't have your fancy little line you can drag, but your pencil works perfectly. Put it vertical, drag it across. See if it ever touches your graph in more than one point. You have two more. 1 second, I want to get my vertical line. Actually, I don't think I need it. I take that back. So anyway, we have two more. These are discrete graphs. They are not continuous, so they are not connected. It's a little easier on a discrete graph than a continuous graph. If you will look at any of your points, do any of your points line up in a vertical line? None of these points line up in a vertical line. You don't have a dot above another dot. So this is a function. None of these dots line up with each other in a vertical line. But the next one, if you will look, this dot and this dot line up in a vertical line. So do these two. So do these two. Which means that if I put a vertical line on here, it's going to touch this graph in this point and this point. So it's going to touch it more than once. So this one is not a function. So in short, a relation is a set of ordered pairs. A function is a relation where none of the x values repeat. And the quickest, easiest way to test if a graph is the graph of a function is to use the vertical line test. And if the vertical line touches the graph in more than one point anywhere, then what you have is not a function. Okay? If it only touches it in one point and it never touches it, in one point only, you're fine. So that's functions and relations. We will practice this tomorrow when you guys come to class. Have a good rest of your evening.